Okay, so good morning everyone. I think you are now able to see my screen. So we'll again in the lab session, we'll again do the same thing we did in the last class, right? So the thing is, I will send you these files. I will before sending this, I will describe what you have to do here, just like the last day. But last day, what I find disappointing is that you shared the same code and you submit the same code, most of you, right? So you got the marks accordingly. I could not give you much marks for that, for copying and copy pasting the same code. Okay. So what you can do, if you have problem, you can obviously discuss it with your friend, but you cannot send your friend's code. Okay, by changing your name and all. So there are tools using which I can find out whether it is the same code or not. So please don't do that. Try to write it yourself. The students who have tried by themselves, even if they have got the answer wrong, even if they have got the logic a bit wrong, but they have got higher marks than those who have just sent me the code taken from their friends. Okay. So discussing the problem, discussing how to do the solution is the one thing, and submitting the same code, submitting your friend's code is not the same. Okay. So I will request you don't do that. Write the code yourself. Even if it is wrong, you will get higher marks than copying others' code. Okay. Uh, so, anyways, I hope from the next time onwards you will do this positively. Okay. So, coming back to our today's session, today we'll have two problems. Okay, one is for fractional knapsack, another is binary knapsack. So both this problem has been covered in your theory class. So in lab, actually, lab sessions, I do not have much thing to do. I can only describe you what you have to do, and you have to do it yourself because the algorithm is available with you, right? So let us start. So first of all, the fractional knapsack. Another point is last day I shared a common space where you can submit your code, right? So today what we will do, I will not share any common Google Drive space. Okay. Uh, I will share. I will upload this file in the Google Classroom, and I will make a copy for each of you. Okay. So what you will have to do is when you get the assignment, there will have an option like handed in or turn in. So you write your code, you copy paste your code in the file that is generated for you, and then you submit it and turn it. Okay. So that is how you have to do. So there will be no common drive space from this time onward. Okay. So anyway, what you have to do, so again similarly you have to write your details over here in this comment section. So this problem is for fractional knapsack, and another is for binary knapsack. So in fractional knapsack, what approach we follow? We follow the gray approach, right? So what we will have, so again, so what if you can remember in fractional knapsack, we have to sort the jobs based on your profit per weight ratio, right? So we have to sort the jobs in descending order based on the profit per weight ratio. Now each job is associated with a weight and profit, right? So the jobs, the weights and profits will be given to you as an array. So what we will have to do is to turn those array into a job structure. Okay, because when you sort the array of if you have the profit array and weight array separately, and if you try to sort out them based on this profit per weight ratio, the job index will be messed up, right? So to prevent that messed up, what we will do, we'll create a user defined data type. Okay. So now here we are not dealing with job, we are dealing with item. So in this binary knapsack problem, what we'll have an item, and each item will have four properties, right? One is its item number. Okay, another is profit, another is weight, and another is profit per weight ratio. Okay, so we will create a user defined data type. Uh, Suppose item called item. So you have to create those data type over here, and that should contain these four properties. Okay. Now choose the data type carefully of this property, because this profit per weight ratio, especially this profit per weight ratio can be fractional. Okay, so you have to keep that in mind. So create the user defined data type over here. Okay, and next I will explain it from main. So in main, what you have to do, so again like the previous days, you have to take the input from user first. Okay, so first you have to take the number of items that are under consideration. So suppose the number of items is 8, then you have to create dynamically two arrays. Okay, one of size n, one is for profit, another for weight. Okay, and then get the values from the users for these two arrays. Okay, so we will get the values for the profits and weights of n items. So once you get this profit and weight, the finally you have to get the capacity of the knapsack from the user. So there are four type of input. One is, first is the number of items, second is the profit of all the items, third is the weight of all the items, and finally the knapsack capacity. So once you got all the inputs from the user, what you have to do, you have to pass these two arrays, means the profit array and the weight array. Okay, and the item count. So this item count, all these things you have to pass into function one, where you have to convert it into a single array of structure. So of the data type you define. So you created the data type by this time, right? Here. Now you have to write the code here. This will take the profit and weight array along with the item count, and then it will uh, create a array of structure of the items. Okay. Now here you have to automatically assign the item number and the profit per weight ratio by calculating from this two arrays. Okay, profit and weight array. Okay, so here you will create a structure of items which will contain all the details about the items. Okay, so once you create this array of structures, you have to return that to the main, so to the function where it is called. So once it is executed, you have now the array of items with you. Okay, now what you have to do, you have to pass the structured array of items to function 2. So in function 2, what it will do, so that will sort the items in descending order of their profit per weight ratio, right? So that is was, if you can remember, in our theory class, what we assume that the profit and weight array are given in sorted order of their profit per weight ratio, right? So now what you have to do, you have to sort the array based on their profit per weight ratio in descending order. So in the function 2, you have to write the code where it will sort the array of structures, basically uh, array of structures of type item. So it will sort those structure array in descending order of the profit per weight ratio. Okay, so you can write any algorithm, again n log n algorithm will be preferred. Okay, uh, so write your code here. So last day I found that some of you has skipped this comment section and write the code just word main. Okay, all the code, all the function, don't do that. uh, so there is space. So for you define the structure over here, you write the code of function one over here, you write the code of function two over here. So okay, this is one thing. Another thing is, you can always give a suitable name to function one, function two. Many of you last day did not give any name, you just write function one, function two. So you can also give a suitable name for that. Okay, okay. So once the function 2 is being called, once the function 2 is being executed, what we have to do, so it will return you the array of structure of items in sorted order, in descending order of profit per weight ratio, right? Now what we can do, we can now apply the algorithm of finding out which items to be selected and what is the fraction to be selected, right? So for doing that, we'll call the function 3. Okay, so function 3 is the function that will implement our fractional knapsack problem. So in function 3, what we will pass, we will pass the shorted structure of items, right? So if you can remember, in theory, what we did, we have the shorted items, right? So we have now already sorted the items. Now we'll have the sorted structure of items. We'll have to pass also the capacity of the knapsack and the items count, okay, in the function 3. And in the function 3, it will now select the items and the fraction of the items that has to be taken within the knapsack, okay. So the function 3 will return you an array denoting which objects are taken and in how much fraction the objects are being taken, okay. So if you go to function 3, the description is also written here. So write a function that will take the sorted structure of items, knapsack capacity and items count uh, as input and produce an array, suppose x, okay. So that array x will be your you can say selection array, okay, or fraction array, whatever you can say. Suppose this is a fraction array, okay. So so this function 3 will produce a fraction array of size n, that is input count, which will hold the fraction that is taken in the knapsack of an object. So it means the ith element in this array x will contain the fraction that denotes the how many fraction of the ith object is being taken. Now this ith object does not the ith object actually means the item number should be I, okay, not in the sorted order I. So remember that. So the ith element of x should denote the fraction of the item number I which is taken, okay. So it is clearly mentioned that this is the item number I. So it is not that it is in the sorted order. Original item number it should be I, okay. So this function implements the fractional knapsack algorithm. So as I told. So once this function is executed, it will return you the array of fractions of the items, okay, that are being taken into the knapsack. So once you got the fraction array in your main program, what you will do, you will pass the fraction array along with the profit array and the item count into function 4, okay. So function 4 will now calculate the maximum total profit that can be earned by placing this item into the knapsack. So you now will have the fraction array, it means which object is taken in how many fraction, and you will also have the profit array. So we will have the proportionality over here. So you have to multiply the ith fraction with ith profit, and then you have to find out the total profit that you are getting, okay. So this is what you have to do in function 4. So write a function here that will take the fraction array as produced to function 3 and profit and it will also take the profit array and item count as input, and it will finally return the total profit that can be earned by taking the item fraction in knapsack, okay. So once it is done, what you can do, so once this computation has been done, next you have to print the fraction array. It means which object is taken in which fraction, and then the total profit that has been earned. So that is written by function 4, okay. So this is what you have to do for the fractional knapsack problem. So before I going to binary knapsack, I would like to ask you that whether it is understood what you have to do or not. If not, you can ask your question, your doubt out. So, okay, nobody asking anything. So the next thing that we will do is the binary knapsack problem. Okay. So in case of binary knapsack problem, again you write your details over here. So in case of binary knapsack problem, what will happen? Uh, we do not need any structure over here, right? Because we are not sorting the items based on any property of the item, right? So the items will be in their place only, the way they are be given as input. So what we have to do, we have to implement the binary knapsack problem over here. So let us see what we have to do. So first, okay, so let us go through from the main. So here it is the same, okay. So you have to take the input from the user again take first the number of items to consider, suppose n, then dynamically create two arrays of size n, one is for profit and another is for weight. Okay, now get this value of from the user for these two arrays. Okay, and then get the capacity of the knapsack from the user. So this is same, so you can just copy paste from your solution of fraction and knapsack over here. Okay, so these two portion is same. There is no difference in the input section for fractional knapsack and binary knapsack. Okay, the only difference between these two problems is we cannot take the objects in fraction in binary knapsack, right? In binary knapsack, either you have to take it in full, otherwise you have to skip the object, right? So next, what we'll do, once we get this input, we'll pass the inputs, all the inputs. Okay, so all the input has to be passed in function one. So all the inputs to the item count, profit array, weight array, and the knapsack capacity. Okay, so all the four items has to be passed to function one, which will return you the cost table. So if you can remember, in the dynamic programming of the binary knapsack problem, we made a table following an algorithm, right? So the algorithm returns that was the cost table. Okay, so that algorithm, this algorithm or this function will return you cost table from that from this. So this cost table will be generated using the dynamic programming algorithm. So if we come to function one, so you'll have to write a function that will take the profit and weight array, the knapsack capacity, and the item count as input, and produce the cost table that is generated by the dynamic programming algorithm. So this function will implement the binary knapsack algorithm. Okay. So we have the slides with you where the algorithm is written. What you have to do is to just follow the algorithm and implement the algorithm, write the code for this algorithm over here. Okay. So you will write the code that will create the table, the cost table, and this from this function we will return this cost table. Okay. So once this cost table, once we get the cost table, what we have to do? So if you can remember, there was another algorithm written which actually determine what are the items that we have to take, right, from the cost table itself, right? So in the second function, what we have to do is to pass the cost table and the weight array and the knapsack capacity and item count. Okay, so weight array, knapsack capacity, item count will get from the input, user input. The cost table will get from this function one. Okay, so this cost table along with these three input we have to pass to the function 2, which will return the array denoting whether an item is taken into knapsack or not. So since this is a binary knapsack, there is no concept of taking an item in fraction. Okay, so what will we do? So in this function, we'll pass this cost table, the weight array, and the knapsack capacity. Okay, so the item count, this will be passed to this function will take the cost table, weight array, knapsack capacity, and item count and input, and produce an array X, which will be used to identify the items being selected into knapsack. So since this is a binary knapsack problem, so this Xi can take two things, right? So the value of Xi can be either 1 or 0. So if Xi is 1, it means the object is taken into knapsack. If Xi is 0, it means the ith object is not taken into knapsack. Okay. So this we'll call this as selection array, because the value of this array actually determining whether the object is being selected into knapsack or it is not being selected into knapsack. Okay. So so this function will take the cost table that is generated by function one, and along with that the weight table, the weight array, the the knapsack capacity, and the item count into as your input. Okay, and it will return the selection array as output. Okay, so it will return the selection array, and then what we have to do, then we have to pass the selection array, the profit array, and the item count to function 3. Okay, so the functionality of cost table has been ended as soon as we got the selected array. Okay, selection array. So we get the selection array from this function 2, the profit array and the items count, uh, and we'll pass these to function 3. Okay, and this function tree will compute the maximum total profit that can be earned by placing the items into knapsack. So this is similar to the function code of the previous program. So almost similar. So you have to write in function tree that that will take the selection array as produced by function 2 as input, along with it will also take the profit array and item count as input. Okay, and it will return the total profit that can be earned by taking the items in fraction items. So we do not have fraction, right? So, taking the items in knapsack. Okay, so that is what it will do. And finally, what you have to print? You have to print the selection array, means whether the ith object is selected or not. So this selection array you have to print along with the total profit. Okay, total profit that is earned by taking those items into knapsack. Optionally, you can also print the cost table. So you can also print the cost table, uh, and you can verify it with your answer. I mean, suppose you try to do some problem in your home of the binary knapsack, and you created the table, you solved it, but there is no way to judge whether you have done it correctly or not, right? So if you print the cost table, so yeah, you can judge now your answer, whether it is you have done all the calculation correctly or not. Okay, so I am putting it up to you that whether you will print the cost table or not. It is totally up to you. There will be no advantage or no disadvantage if you print or do not print the cost table. Okay. So this is it for this is it for binary knapsack. So if you see that binary knapsack will take less number of code, because we do not have to sort the items and all. We do not need any other structure. We do not need to convert it from the arrays to the structure. Right? We have to just simply implement this algorithm and we'll get the answer accordingly. So that is it for the explanation of what you have to do. So if you have any query, you can ask what you have to do if you are not clear. Okay, no further questions. So I will share these two files. So as I told you during the start of the class, so I'll share this two file with you using Google Classroom platform, and in that platform there is an option that send a separate copy for each of you. Okay, so I'll do that. So you will have a separate copy for each of this file. Okay, so what you will have to do, you have to write the code. You have to copy and paste the code in the Google Classroom separate file that is created for you, and you have to submit it back to me. Okay, then there will be no chance of I mean there was if there is a shared place, then what you can do, what the student you can do actually is you can see others code, you can take others code, all those things can is possible, right? So in the separate file case, that thing is that possibility is now invalidated. So I now expect that you will write your code of your own and don't take others code. Okay, don't do anything harmful. I mean, probably Shayan Ward has told that he has submitted the file, but that is not present there. I don't know. Anyways, so this kind of mistake will not be there anymore. So you you write your code, you copy paste in the separate copy that has been sent to you using the Classroom platform. You paste your code there and you submit it back to me. Okay. So that will be one thing. And so since there is two problems now, so you have to submit it by Saturday. Okay. So you write this code. Okay, by Sunday you write this code. You take your time. You think, you discuss with your friends, but don't share your codes with your friends. Okay. So so submit all these codes all these two codes by 12th of April. Okay. Okay, and about the next class should happen on 16th, but that will also depend on the lockdown. Okay, so if the lockdown continues, we will take this online session likewise we are going. But if the lockdown is taken back, then uh, probably we have to go to college, and I don't know whether we will be coming to college or not, because still it is a there is a chance that the infection disease spreads. So that's up to you. So let's see what happens, what the government take the decision, and we'll act accordingly. Okay. So the thing is, we'll take the online session on 16th. If the lockdown continues, if not, then we'll have a session in our lab. Okay. That's it. And this your attendance will be given based on your submission of your assignments. Okay, so if you submit the assignments, then only you get your attendance. Because if you attend this session or not, because there are many students who complain about this online streaming problem, so they are not probably able to join this session online. So this session is being recorded and uploaded to YouTube, so that they can see it at their convenient time when the network permits them to see it. Okay, so to so if I take the attendance now, that will not be a good idea, because they will be missing those who are doing it later at that time, right? So I will take your attendance based on if you submit the assignment or not. So if you submit the assignment, then you will get the attendance. Otherwise, you will not get the attendance. Okay. So do your assignment, submit it by the deadline. Okay. So again, we are at the end of our session. So if you have any question, please ask. If you have any doubt, if you have any question, please ask. Okay, so nobody is asking any questions. So I hope it is clear to all of you. So again, if you find anything doubtful, if you have any queries, you can post it in Google Classroom, or you can also ping me in my phone number. Uh, and again, do not share your code. You can discuss. There is no issue. If you have any problem implementing the algorithm, you can always reach out to me. You can discuss it with your friend, but do not copy paste your friend's code, or do not write it, take the file from friend and just send it to me. Okay, don't do it. Okay. So anyway, so ending today's session. Have a great day, and do your study accordingly.